Hello, everybody. So hi, my name is Jakub, and today I'll talk about this petrol station simulator. So that's the best way to spend your time, anytime. As you'll see, everything is written in Ruby. This is how it should look at the end. The car comes to a petrol station, you give it gas, every pixel Ruby, right? So it works like this, actually. So we will see something similar, but I will make some close-ups so that we can look what is happening and why is it happening, etc. And yes, this is not JavaScript. We can also have our nonce, butter nonce and everything in Ruby. About me, my name is Jakub. As you see, that's my surname. I'm from Poland. I do Ruby since 2008. It's funny, I started in this company called Yes. My shout out to the companies I worked for. UFXing, John & Bros. These are some companies that I'm happy to have worked in and learn Ruby and deliver nice, hopefully, production code. Then I had 1 year with Elixir as well because I thought, oh, I'm getting in a path of sorrow with Ruby. Everybody's dying, so I need to go to do Elixir. And I tried, it was fun, but then I said, okay, let's just go back. And I got kicked out from Fresh, and then I joined other companies, and currently I work at Puncta. So we are a car insurance and comparison engine, and hence the petrol station, right, comes together. So, yep, just seeing the presentation that we had before. So I already have tools and I won toys. This is what the project that we're going to see is kind of Boys Will Be Boys project. And petrol, smells nice. And as you work with your code and you've seen so many production, business, web, application, back-end, front-end coding, you just want sometimes to do something else. And hopefully you do a simulator like I do. So my kind of main thing here is to inject an idea for you to do simulators in your free time. The code that I will show, of course, is work in progress and open for issues. And I would like to ask you that not everybody come at once with your issues and pull requests, okay? It's just easy. I don't have time to review everything. Now, I'll show you some Rust and C things so that this will be very smart now, right? And before that, I want to show you that I'm a Ruby certified programmer, okay? I don't know if anybody knows that there is something like Ruby Association and they do certification. And I actually went there and they checked all my body that I have nothing that I can cheat from, you know? And I made it, and there is another step to it. You make a golden certification. Anybody has the certification of Ruby? Anybody? Who's using Turbo? At least. One person. Did he make golden step? It's a really interesting path. Of course, everybody can laugh at certificates, but you really need to like dig down what is happening there, because then you get questions. You're running out of time, and you need to click. You know, so it's good to review Ruby. Anyway, when I was doing this project with Petrol Station, okay, enough of my face. Then I ran into some problems about timers, because as we will see very soon, to make a simulator, you need a custom timer, something that you can speed up. Let's say I want my simulation to run 10,000 times faster than I would normally wait for 1 second to run, and I want it to work as if it was running a second by second. So I ran into some sleep granularity delay, and I was checking how this, sleeping is actually implemented. I didn't understand much of the code, but I was trying to to get deeper to see how C implements that. And the results for Ruby, when I try to what I was trying to do when you do the simulator and you try to speed up time, is you need those ticks to be in the time you want. So if your simulation is of speed 1, you want the sleep to be 1. But if your simulation time is 10, you want 1/10 of a second to be the, the quantum of the time, let's say, inside of your simulation. So when you measure that, and you measure it for 1 second, 1/10 of a second, 100th of a second, a millisecond, and so on, you start to see that this sleeping also takes time. It's not just for free. And once you get to a microsecond, you're getting a 4-second delay when you run it many times. When you run it for 1,000,000 times and you try to sleep for 1,000,000 times, for 1 microsecond, you're actually getting a delay of 4 seconds. It's not 1 second, right? So I was interested how Rust does that, and we in the Ruby community, we have to see what a JIT compiler is and so on, and these things are written in Rust, so it's good to sometimes look inside of that complicated language. And I did those sleeps, the same sleeps. And what was funny is that it was running a little bit longer, for the microsecond and for the millisecond as well. And then I was, okay, my code must be wrong, something's wrong. Then I wrote it in C. Of course, I didn't, but this is the C code that you see. And the same with Rust, okay? Don't worry. And the final countdown was that using those three, actually C, of course, was the fastest. So then you can see that that Ruby is using that C libraries underneath, and they're faster than those that Rust uses. At least that's one kind of understanding of that. If anybody has a different interpretation, I'm happy to know why, But then coming back to my presentation and the petrol station. So here are the building blocks of that petrol station. We have a car, and there will be many cars. There is a dispenser, so something that pours the fuel into the car. The station, that is a bank of fuel, basically, that needs to know when it can handle a car inside and when it has to halt it. The queue, that will, manage all those cars that are coming and letting them know that they can go. And the queue consumer and the runner. So I'll show you these in a code. We'll slowly look at them. If there's some, time management, I'll also look at my own thread over here, because everything will be around threads. Good. All right. So that's also a basic how it will work. There will be one main thread that runs timer, which is, you run a Ruby script, there is one main thread, right? The current thread and that. And this will create other objects, like, the cars. It will create the station. And then those objects will run in their own threads. And what they will share is that station object from which they will pull gas. And also they will all have access to our custom timer. That is the core of the simulation. So that they can see at what tick the timer is. Then the other threads do their thing. And we'll see that we can actually configure the speed and other stuff of the timer here. So, to show you a bit how this code looks like, we have this app of these things that I just mentioned. We have a runner task. and some tests. The gem file is very simple. There is no additional thing happening here, just something for debugging and testing. And let's take a look. Let's read the code as a little book. And hopefully, if anybody has a question, just raise your hand and let me know. Don't need to wait. So there is one thing that the car authority, and that basically gives the plates to a car. Is everything visible? Good? Yeah? Good. So, you know, something that you want to request a plate, it generates it and distributes it, and at the end you have a car with those plates. Then you have a car that has 3 attributes: the plates, the tank volume, and the tank level. So these are randomly assigned to the car at the runner time. Then, so this is not much complicated. It has these this public method of fueling the car that actually it, you know, it adds the gas to itself. Then we have a station, which is a bit more complicated. It has a fuel reserve and it has dispenser. And later we'll see also that you can add more dispensers to it. So because the fun with simulation is, and you will see it every time you try to simulate some system, is that you can just go on with ideas. It's never ending. You have more dispensers. Okay, now we can have 2 stations. Okay, so can I fork the stations, or should I make them in Fred stations? How should I make a simulation that spawns many simulations of one scenario and then collect data and then see what's the result? You know, it can have some business value as well. So you're initializing a station with the fuel reserve, with dispenser. You're mounting that dispenser to the station. You have some basic methods like open the station, close the station. Then there's a logging happening. And the main method is to request the fueling for a car. And then some, you know, it collects data like how long a car was waiting, how long did it take to fuel the car, etc. And yeah, and one of the check is that if there is enough fuel over here. So the handling of fueling is that the dispensers fuels the car, and we subtract the fuel from that much that it needed, you know. And for the sake of simplicity, the simulation is like when the car comes and the tank volume is 70 and it has 20 liters inside, then it always wants 50. It always wants to tank up to fill the volume. So something more interesting now is the queue, something that glues the car with the station. So when you're playing with things like that, you need to be very careful. And this code that you see is not very careful right now, because such objects like arrays are not thread safe, and you would need to use thread queue to do that. And we'll talk about that later, how to think about threaded code later on. But now we see very basics. So when you push a car to a queue, it's putting into a waiting list. It has a stamp of the car came at that time, this entry tick. So as you see, the timer is here, that the one that I talked about, that we have one timer and we have access to it to see where we are at in the simulation. We have those nice informations logging that the car has arrived and it's in the queue, or that when you want to fuel, because there will be this queue consumer, when you're taking when you want to fuel but the station is already closed, then you get a message that the station's closed, or there was not enough fuel in the station and the car just run away. You know. So all these things like taking from the queue and adding to a queue, they are not thread safe here. Just make sure these structures are need to be overridden. Now, the runner is probably the most interesting part because we'll see the main thread, what is happening, how we can set up our simulations. And for now, let's think about it as a script. But of course, you can take the whole simulation and turn it into a class as well, and then run it as something that you can run many times. But this is like a one-threaded line. So we have this simulation speed, and that is 1,000, right? So we go for 1 millisecond. 1 second equals, in real life, equals to like 1 millisecond in the simulation. You have the simulation ticks, so when do we want this to be over? Oh, what is it? Now, there's also a simulation tick step, because we are so much in control over the timer that we can say, okay, just refresh every second step or every fifth step, but it's set to 1. Number of cars, what are their settings of volume and level, and delay in which they are coming to the station. The station fuel reserve, the dispenser's fueling speed, because if you look at the dispenser, it just calculates like the amount of seconds per liter. And those seconds are, of course, in the context of the simulation speed, right? So first, we configure that timer. We say what is the simulation speed and the tick step, and we create such stuff as dispenser, station, and the queue, and then we start with the threads, right? So the thread is not a thread, worry not, although I was really sometimes lost when doing that threaded stuff, and but it's good to get your head around it from now and then. So the station thread is basically opening the station, and then it waits until the closing tick of the station, and then closes the station. Not much to do. Now the consumer thread is consuming the queue and see if the simulation is over. Then it stops. That's the loop of that one. And if it tries to consume, but it cannot consume, then it waits here for a while, and it will consume it on some point. Now then we create the cars, and for each car we also create a thread. So the thread of the car is that we wait this random amount of seconds before the car actually arrives to the queue or to the station. And at the end we're showing all the messages of, oh, this is what happened. Some calculations about it. So I'll show you how it runs right now. Let's see. Okay, we made it, didn't blow up. So we can take a look at it. So there is a simulation with the speed of 1,000. Closing tick of the station will be 400. And we're expecting 5 cars to arrive, and this is how much fuel we have. The speed of the dispenser is like this. So here you can see, let's see if there will be some interesting parts here. At tick 26, this car with these plates arrived first and is first in queue. It waited 0 seconds to start the fueling, and it started the fueling, and there was nothing happening in between. It got fueled in 76 seconds. Then another car has arrived and is first in queue, and it starts queuing, and meanwhile other cars come and they are in the queue. And then this 5th car, this one got fueled, and it turned out that the one that was waiting in the queue needed 56 liters and has left because there was not enough fuel in the station. And the same happened to this car. But there was another car that came, and yet, okay, this one also didn't have, the station didn't have that much gas, because there was 21 liters that left in the station. So if there would be a car that came and it needed just 20 liters, they will give it to him. Why not? So the most important, let's say, a business metric, right? Because we're talking about business here. Nobody knows we're playing, but this is business. Look, the average wait time, like the stations can say, okay, with this setup of our station, our customers wait only half a second to get their fuel. And the fueling time is like this. And then you can think, okay, so how can I make this number better by paying as less as possible, no? As little as possible. So maybe we should buy 3 dispensers with slow speed, or just 2 dispensers with a bigger speed, and then see a global simulation how these will handle the traffic, and at the end give you the advice, okay, go for that for your budget. So of course this simulator doesn't do that yet, but it could, all right? So let me show you the timer also. Is any questions? Something is not clear or something? You good? Yeah? Good, I'm happy. All right, so let's look at the timer. The timer initializes, it's a singleton that has those 3 elements of current tick, the tick step, and simulation speed, and these are the defaults. You can configure them like you see here and like we did in the runner. So with that configuration, we can pass the simulation speeds that we have in the constants. And now, when you see the runner here, before we start to join the threads, and the join means that all the threads that are mentioned in this array are being joined to the main thread. We're starting the timer, right? And after they're complete, we're stopping the timer. So what the timer does, it's in its own thread, it's waiting for the right amount of time and then making the tick. And waiting is actually that only place when we sleep. That's where we were talking about the sleep granularity in Ruby, C, and Rust, because it gives you the idea of how much can you speed up that simulation, no? With 1 microsecond, that's too much, because the results you're going to get are not fine-grained or... Now, but when you have the tick, let's see what the tick does. Yeah, it's just setting the current tick with another tick step. So we're adding, and then another loop comes, you know, another cycle, and we're waiting and ticking, waiting, and that tick duration takes is that simulation speed. So let's say if we try to run it with some, you know, horrendous numbers, it runs very quick, and it runs quick, and it probably even runs well if you look at the ticks over here and so on. But it's you start to have problems when you put like number of cars like this. You know, when you go really big with that, you can have a big car reserve and go crazy. Oh, and go like that. You start to see that it's slowing down, or okay, wait, let me. That's a work in progress. We're playing here, okay? I'm telling you not to worry, but I'm telling it to myself, you know. You know how it works. Don't worry, Jacob. So of course we'll not penetrate through all that. But you can see that if maybe the speed, even that it's so high, doesn't make so much trouble. Can change some delay. So this, if I create that higher here, then we'll expect the cars to come in different times, not just all of them at once and queue, but they'll come randomly. And see. Okay, let's try that. I know this is just flying numbers, but then what you can also see is that things are starting to get slower, and you can see that this Ruby is having more threads and those idle wake-ups. So these are all the things that I encourage you to play with when you're going to download my code, right? To adjust. But yeah, the nice things, let's take it slow. Everybody's sipping beer right now. So let's just make a simple simulation. Then let's go slow, maybe. Okay, let's do the simulation speed like 5. We'll have 5 car numbers and a lot of gas. And let's just relax and see that they are coming. Station opens. Don't do anything. Let's see if I change the cars random, because otherwise we're gonna wait forever. Okay, I didn't. So let's say that they're coming like that. Oh, something's happening slowly. The cars come, it's first in the queue, it's fueling. Another came, it's waiting. And it's such a joy when it starts to really work, when you look at this and you say, oh, this is nice. And you look, because so many times these numbers didn't match, like the seconds were not happening, this was not happening, something went wrong. So now you see everything is nice. Now, I have some stuff over here. Okay. Oh, that was too fast. Wait. Let's go. I now did something like, there are many queues, you know, there are queue numbers too. And this is when we can start to talking about thread safety and so on. But there is not, I think, so much time that we have. But I will show you how much time do we have still? Around 5 minutes, 10 minutes? Easy?
We don't measure time.
You guys, oh, you don't measure time? I have my own timer, so I can go, you know, I can speed it up, slow it down. You guys, you know, you don't decide, I decide, look. Okay, okay, so easy. I try to play with with putting more queues, because I thought if there will be more queues, then maybe this traffic will get sorted out better. But this will actually not make traffic go faster, because you will need to have more dispensers, and each dispenser would need to be in its own thread. And I went that far on another branch, but then it has some other problems. But the one with the queue is that you start to do stuff like those mutexes synchronize. Because Otherwise, they are, trying to get the same resource at the same time, and there's a problem. And to understand who works with threads and who's comfortable with mutexes, can you raise your hand? One person. So I would raise my elbow as well, but if you want to raise your hand, then first I recommend you that website, Working with Ruby. Anybody knows about that website? So there's a guy who wrote those 3 books, and they're online, and one of them is about Ruby threads. And he talks about all those interesting things, like how the Jill works underneath an MRI. Although the book is in Ruby 2.0, but it's still quite, how do you say? It's still up to date with all those things. Maybe a part of, I think he wrote an article about fibers in being parallel in about parallelizing fibers. I have his article here. Is that him?
No.
No?
No problem.
Oh, okay. Oh.
Please read it.
Yeah. This is a good article. Read it. You will see where Ruby is parallel, where is it concurrent, and of course, you'll read about those fibers, which I thought of using them inside the distributors, because they seem like the thread is in its own thread, the station is in its own thread, so maybe distributors could be the fibers inside of a thread. That could be nice. And especially the Ruby 3.0 introduced the non-blocking fibers concept, and I'm really interested how it's going to play out with those petrol station simulation. But the real introduction, apart from that excellent article by Visuality, is this. And if you can, I think it takes like 3 hours to read that, and it's a good read. And also, if anybody knows Graceful Dev, yep. So Avdi Grimm is making a good job of explaining what is happening there. Especially good for, how many of you would call yourself a beginner Ruby developer? 2. Intermediate. Expert. Wow. So, because I saw 6 hands altogether. And I wonder who's the rest, In between.
Not expert yet.
In between, all right.
We are not certified.
We are not certified. Who am I talking to? Come on. People. Always people. Okay. So we made a run, and I'll not slam you anymore with that certificate. No. It's with the code and the simulation. We have seen what is happening, and we can imagine that there will be more dispensers, so those cars will come in queues differently and so on. What I really want my next step to be is that I write this, and in my config YAML I have these scenarios for simulations. And I'm getting a response from that I'm running 5 different scenarios, 10 each. So let's say in one scenario I have 1 gas station with 2 dispensers running at speed of 0.4. And in the other scenario I have 1 station with 4 dispensers running at 0.7. And I want to see if I run them 100 times each, what will be the averages of waiting time and fueling time for my customers. Then I'm aggregating those results from all the forks, because this is a place where we can run in parallel with Ruby. We're just forking those simulations, and that much processors as we have, that much we can optimize it or parallelize that. Then we show the best options, and we can make a protocol out of it, which is another step of nicety that then you don't need to simulate a petrol station. You can simulate something else. You know. Anybody has an idea of a different simulation?
Yeah, if we can simulate how much beer we need on our meetups.
Exactly, one thing. And there is also queuing happening, right? Where should you put your casks of the beer? What kind of beer? Maybe if you put alcohol beer, then the presentations are slower, or they're better, you know, or at least they're better received. So, and then you can measure that metric. So places to learn from about that, as I told you, this workingwithruby.com, really good read. The guy, I was impressed to read how concise the language is, the examples he gives. If you never worked with threads, that's the best place to start. Then watching some graceful devs, although this is like, you know, many different short videos on some topics, but you can get a lot from that. And that article you did, guys, is also nice. I appreciate. So if you feel like you like the simulation, then go ahead, write that on your mobile or whatever, give it a star, and you can contribute. I'm waiting for ideas, and maybe not for ideas, but some other hands to play. Many stations, fiber dispensers, money counting, buying drinks and pierogi at Orlen stations, you know, configurations, visualizations, etc. This could be fun. All right. So, are there any questions? Yep.
I have a quick question. So you said that there are some concurrency issues with multi-threading. Have you tried to run your simulation using like JRuby or TruffleRuby?
Yes, I tried with JRuby, and I didn't have better results. And I used the latest version of JRuby, and I thought that just running the code as it is should be enough. But there was some, I can show you even, there was some weird things happening. No, that's a quickie. Did you mean petit? No, wait. It's your main. Did I?
You haven't checked out the master?
No. Oh, sorry. It's your main. Right. Oh, this one looks correct. I think I will get advantage of JRuby if I go with like many dispensers and really seeing if I need to do something more about you know, those fibers. If JRuby can handle threaded safe in its own machine and have it fast, why not? Then I'm a little bit like also concerned that JRuby is now in sync with Ruby 3.1, and Rubinius is probably like 3 or 5 years. The last commit was there. So I want to make it with MRI more than anything, but yeah, I'll try at the end, you know, when I will need to make all that big simulation to run with JRuby and see the results. Sure, I've thought about it. Thanks. Any other question?
Are you doing this for fun?
Yeah. Yeah.
Yeah, that's nice.
Have you thought about showing it somehow? I think like the visual layer.
Yeah, did you see the first slide?
I'm still waiting for that.
Yeah. So yes, as you saw also on the last slide, I was talking about visualization. One very good proposal I got from a here colleague. She said, yeah, just try imagining it. That's the fastest implementation. And I think it's good. But what else? WebGL and sending it to browser. I heard this new talk on Ruby on Rails podcast about WASM, and that you can compile that to WebAssembly, and maybe that simulation can work completely in a browser, and joining it with WebGL can create some results.
Just take CSS, absolute position.
And the frog.
And the frog, yeah, I can show you.
Yeah. Do you think that is your frog concept open? It doesn't have an API that I can throw my data to. And
the only difference is that you probably, well, you don't position the card; they just appear.
Yeah, they
so
appear.
Basically,
I know they are positioned in a queue, right?
yeah, so if you connect my frog and Michał's jokes from
Yeah.
you don't need
I'm envisioning a great adventure, my friend.
If you want to make it 3D, then
Yeah.
you need WebGL.
Yeah.
For anything other, you need
CSS.
CSS, that's
All right. Yeah, of course. I can try. Yeah, I'll see in your code how's this visual. I remember you were showing once that that there are images on the front end, and you're handling them like the sprays, right?
pretty much.
Yeah. I could try. But I don't know how to send that much data so fast to the browser. Maybe with the slow simulation times you can do that.
Yeah,
Why not?
Yeah, I'll show you.
All right, all right. Okay, we have a deal. Oh.
Your time is ended.
All right. Good.
So we have